March 9, 1941. 3:47 a.m. Bletchley Park, England. Alan Turing stood in Hut 8, staring at a piece of intercepted German naval traffic that shouldn't exist. His hands trembled, not from cold, though the March air cut through the wooden walls like a knife, but from exhaustion. He'd been awake for 31 hours straight. The message in front of him contained coordinates for 17 U-boats, currently hunting a convoy, carrying 140 0 tons of food and ammunition across the Atlantic. The convoy had 41 merchant ships and 387 souls aboard. Turing had exactly 4 hours and 13 minutes before those submarines reached attack position. The Enigma machine, Germany's unbreakable cipher device, stood between him and those lives. German mathematicians had calculated it would take 20,000 years to crack. Turing had been working on it for 18 months. He was about to prove them catastrophically wrong. Before we continue with Alan Turing's incredible story, we need your help to keep these forgotten heroes alive. If you're already hooked by what you're hearing, hit that like button right now. It tells YouTube to share this with more people who care about real history. Subscribe to this channel so you never miss another story of courage and innovation from World War II. And here's something we love. Drop a comment below and tell us where you're watching from. Your country, your city. We have viewers from Buenos Aires to Berlin, from Manila to Montreal. Are you a veteran? Did your grandfather serve? Do you have a connection to this war? We want to hear from you. Now, back to Bletchley Park, March 1941, where Alan Turing was about to change the course of human history. Alan Matheson Turing was 28 years old that morning, but looked closer to 40. Born June 23, 1912, in Maida Vale, London, to a middle-class family, he'd been the weird kid who preferred mathematics to sports, who stuttered when nervous, who ran 40 miles to important appointments because he didn't trust public transportation schedules. At Sherborne School, his headmaster wrote, "If he is to stay at a public school, he must aim at becoming educated. If he is to be solely a scientific specialist, he is wasting his time." That headmaster was spectacularly wrong. By age 24, Turing had published a paper on computable numbers that revolutionized mathematical logic. By 26, he'd earned his PhD from Princeton. By 27, when war broke out in September 1939, he'd already been recruited by the Government Code and Cipher School, Britain's most secret intelligence organization. Turing arrived at Bletchley Park on September 4, 1939, the day after Britain declared war. The Victorian mansion, 50 miles northwest of London, looked more like a failed boarding school than the center of Britain's code-breaking effort. His first assignment, break the German naval enigma. His salary, £600 per year, less than a middle-ranking clerk. His office, a drafty wooden hut that smelled of damp paper and cigarette smoke. His chances of success, according to most experts, approximately 0. The Enigma machine wasn't just a code. It was an engineering marvel that made German commanders sleep soundly at night. Invented by Arthur Scherbius in 1918, adopted by the German military in 1926, perfected throughout the 1930s, it looked like a typewriter mated with a telephone switchboard. But its simplicity was deceptive. Inside were 3 rotors, later 4 for naval versions, each with 26 positions. Each rotor was wired differently. Each time you pressed a key, the rotors advanced like an odometer, changing the cipher. A plugboard at the front added another layer. 10 cables that swapped letter pairs before encryption even began. The mathematics were staggering. 3 rotors from a choice of 5 in any order with any starting position, plus 10 plugboard connections. 158, 962, 555, 217, 896, 360, 00 possible settings. That's 159 quintillion combinations. German cryptographers had done the math. Testing 1 million settings per second would take 5,000 years to check them all. Even if Britain captured an Enigma machine, which they had, from a Polish mathematician who'd fled Warsaw, knowing how it worked didn't help. Without knowing that day's settings, you were trying to find one specific grain of sand on every beach on Earth. Between September 1939 and March 1941, the British Admiralty tracked 743 merchant ships lost to U-boat attacks. That's 8 million tons of shipping. 14 Riuasanzaran merchant sailors dead, supplies that never reached Britain, food that never fed civilians, oil that never fueled aircraft. The Atlantic was becoming a graveyard, and Enigma was the U-boat's invisible shield. Turing had watched those numbers climb from his hut. Each morning, new reports. Each morning, more ships at the bottom of the Atlantic. Each morning, the same maddening reality. They were intercepting German messages constantly. Radio operators picked up dozens daily, but couldn't read a single word. It was like having a library full of books in a language nobody spoke. Worse, because they knew the language existed, knew the grammar, knew the vocabulary, but every word was scrambled into gibberish by 159 quintillion possibilities. John Mason was Turing's closest friend at Bletchley. They'd met during the first week, bonded over a shared love of chess problems and terrible cafeteria tea. Mason was 24, from Liverpool, a linguistics student who'd been recruited for his knowledge of German naval terminology. He had a photographic memory for ship names and a terrible habit of humming while he worked. "When this is over," Mason told Turing in January 1941, "I'm opening a bookshop, Mason's Maritime Books, specializing in naval history, ironically enough. You'll visit, right? We'll play chess in the back room." They shook hands on it. Turing promised he'd stock the mathematics section personally. February 27, 1941, 11:30 p.m. Mason was working the night shift in Hut 4, analyzing intercepted traffic patterns. A convoy designated SC-67 was mid-Atlantic, 12 days from Liverpool. Mason identified unusual radio activity, 17 distinct U-boat transmissions forming a wolfpack pattern. He spent 6 hours trying to estimate their positions from signal strength and triangulation. He typed up his report. He filed it with Naval Intelligence. He went home to his bunk at 6:15 a.m. SC-67 was attacked at 2:40 a.m. on February 28th. 11 ships sunk in 37 minutes. Mason had been right about the wolfpack, right about the timing, right about everything except the exact coordinates, because he couldn't read the Enigma messages specifying the attack plan. 847 men died. Mason stopped humming after that. He stopped talking about the bookshop. On March 3rd, he requested a transfer to combat duty. "At least shooting at Germans feels like I'm doing something," he told Turing. "This is just watching them kill us in slow motion." His transfer was denied. Critical personnel, too valuable. On March 7th, Mason took a bottle of pills. He was found in his bunk at 11. 2 a.m., dead at 24. No bookshop, no maritime history section, no chess in the back room. Turing didn't cry at the funeral. He sat in the third row of the small chapel, hands folded, face blank. But afterward, he walked back to Hut 8 and worked for 31 consecutive hours. That's where we find him on March 9th, 3:47 a.m., staring at the intercept about 17 U-boats and that convoy. Mason's ghost was everywhere in that hut. The problem wasn't the Enigma machine itself. Polish mathematicians had already figured out the wiring. The problem wasn't the number of combinations. Turing had designed a machine, the bomb, that could test settings mechanically. The problem wasn't even German operational security. The problem was time. Even with the bomb running at full speed, testing 17 576 rotor positions took 20 minutes. But there were still 5 possible rotor arrangements, 10 possible rotor starting positions, 150, 738, 274, 937, 250 possible plugboard configurations. Testing even a fraction of that took weeks. The convoy would be dead in hours. What Turing realized standing there at 3:47 a.m., exhausted, grief-raw, staring at Mason's empty desk, was that the Germans had handed him the solution. Not in their mathematics, in their humanity, in their laziness, in their arrogance. German radio operators were human beings doing repetitive jobs under stress, and human beings take shortcuts. They get lazy, they establish patterns, they make mistakes. Turing had been collecting those mistakes for 18 months. In August 1940, he'd noticed that German weather reports always started with wetter, weather. Every single morning at 6:00 a.m., like clockwork, weather stations across occupied Europe transmitted reports. Same format, same vocabulary, same structure. In October, he'd observed that U-boat commanders frequently began messages with von, from, followed by their boat number. In December, he documented that many messages ended with Heil Hitler, a propaganda flourish that was cryptographically catastrophic. In February, analyzing messages Mason had flagged before his death, Turing found that some naval officers used their girlfriends' names as daily keys. These were cribs, known or guessed plaintext that appeared in encrypted messages. If you knew a message contained the word wetter, and you knew where in the message it appeared, you could use that knowledge to eliminate vast swaths of possible settings. You didn't need to test 159 quintillion combinations. You needed to test the few thousand that could produce wetter in the right position. But the Bommy, Turing's electromechanical code-breaking machine, wasn't designed to use cribs efficiently. It was a brute force tool, grinding through possibilities sequentially. Turing needed something smarter, something that exploited German predictability, something that turned their arrogance into his weapon. At 4:15 a.m. on March 9th, Turing began redesigning the bomb's logical structure on paper. He worked on Mason's desk. It had better light. The air smelled of machine oil and stale coffee. His left hand cramped from writing. He ignored it. The key insight: if wetter appeared in position 7 to 12 of a message and von appeared in position 1 to 6, you could use both cribs simultaneously to create a crib chain that eliminated 99.8% of possible settings before the bomb even started turning. You weren't searching 159 quintillion possibilities. You were searching roughly 2,000. The mathematics were elegant, almost beautiful. The problem was implementation. The bomb hardware couldn't handle crib chains without modification. Turing needed to rewire the machine's logical gates, add 3 new comparison circuits, recalibrate the stopping mechanism. It would take 8 hours minimum. He had less than 4 before those U-boats reached attack position. Any other cryptanalyst would have logged the intercept as unbreakable and moved to the next message. Turing did the opposite. At 4:37 a.m. he woke up Harold Doc Keane, the British tabulating machine company engineer who'd built the bomb prototype. Keane lived in a cottage half a mile from Bletchley. Turing literally dragged him out of bed. "I need you to modify the bomber. Now, tonight, we have 4 hours." Keane, standing in his doorway in pajamas and slippers, said, "That's impossible." Turing showed him the calculations, showed him the intercept, told him about the convoy, told him about Mason. Keane went back inside, put on his work clothes and said, "Let's go." They reached Hut 11, where the bomb was housed, at 5:03 a.m. The machine was 8 feet wide, 7 feet tall, weighed 1 ton, and contained 108 drums each, with 26 electrical contacts. It looked like a demented pipe organ built by a madman. It cost £50,000, a fortune in 1941. Damaging it could mean court-martial. Modifying it without authorization definitely meant court-martial. Turing and Keane spent exactly 47 seconds considering the risks. Then they started ripping out wiring. The work was brutally precise. Each drum had to remain calibrated. Each new circuit needed testing. The comparison gates required hand soldering. Keane's hands shook, not from fear but from the delicate work. One dropped wire, one loose connection, one miscalculation, and the entire bomb bay would be useless scrap metal. Turing held flashlights, fetched tools, read out wire diagrams, and recalculated the logical pathways 3 times to be certain. The smell of hot solder filled the hut. Sparks showered from grinding work. Outside, the sun rose over Buckinghamshire. Inside, 2 men committed technical treason against regulations. At 7:11 a.m. they finished. The modified bomber looked identical from the outside, but internally it was now capable of crib chain analysis, a technique that wouldn't be officially documented until 1943. Turing loaded the intercept. He programmed in 2 cribs, von, likely start, and Strasse, street, common in grid coordinates. He set the rotors to starting position. He triple-checked every connection. Then, at 7:19 a.m., he pressed the start button. The bomb roared to life. Drums spun, relays clicked. The noise was incredible, like a textile factory and a thunderstorm having a mechanical argument. Keane stood next to him, watching dials. Neither man spoke. The machine would either find the settings or burn out trying. At 7:36 a.m., 17 minutes later, the bomb stopped. A red light illuminated. Turing's hands were shaking as he read the output. Rotor order 24V. Rotor positions QWE. Plugboard. AVBS CGDLFU HZ in KM ABURX. He grabbed the decryption tables, started translating the intercept by hand. The first word appeared, Vonvonu 14U, from U14. The second line, Angriff, attack. Third line, coordinates. The U-boats were forming a patrol line at 52 dig 14N, 28 dig 47W, preparing to intercept convoy HX-112 at 12:30 p.m. Turing literally ran to the Naval Intelligence Liaison Office in the main mansion. It was 7:44 a.m. He burst into Commander Edward Travis's office without knocking. Travis, 53, had been head of Bletchley Park since 1942. He was drinking tea. He was not pleased by the interruption. Turing, gasping, sweat-soaked, handed him the decrypted message and said, "We broke it. Naval Enigma. We can read their orders." Travis read the decrypt, read it again, looked at Turing like he'd grown a second head. Then he grabbed his telephone and called the Admiralty directly. The convoy HX-112 received routing change orders at 8:20 a.m. via emergency Morse. They diverted north, adding 6 hours to their journey, but avoiding the U-boat patrol line entirely. The German submarine Wolfpack waited at the designated coordinates until 6:00 p.m. before dispersing. They sank nothing, not one ship, not one life lost. The 17 U-boats that should have been a massacre became a confused patrol that found empty ocean. German commanders assumed the convoy had been delayed by weather. They never suspected Enigma compromise. What happened next was controlled chaos. Turing's modification worked. The crib chain method worked. Suddenly, Bletchley Park could break Naval Enigma messages in under 30 minutes, down from weeks or never. But there was a problem. They had exactly one modified bomb. They needed dozens. And they needed them yesterday. By March 15th, Keane was working 18-hour days supervising construction of bomb number 2 and number 3. By April, there were 7 machines running. By June, 15. By the end of 1941, 49 bombs were operational across multiple sites. Each cost £50,000. Each required 12 operators per shift. Each could process 17,576 rotor settings in 20 minutes. Together, they could break most Naval Enigma traffic within hours of interception. The impact was immediate and devastating for Germany. In February 1941, U-boats sank 196, 783 tons of Allied shipping. In March, after Turing's breakthrough, 120, 958 tons. In April, 107, 900 tons. By May 94, 209 tons. The decline continued month after month. Convoy routing became devastatingly effective. Ships avoided wolfpacks like they had psychic powers. U-boats returned from patrols having sunk nothing, baffled by empty seas. German commanders blamed bad luck, bad weather, bad intelligence. Never compromised communications. But official recognition? That required bureaucracy, and bureaucracy required explanations. And explanations required admitting that Turing had modified an expensive machine without authorization and committed technical violations of established protocol. Commander Travis filed the after-action report on March 11th. He credited the breakthrough to improved statistical methods and enhanced operational procedures. Turing's name appeared once in paragraph 7 as technical advisor. The official commendation went to the Bletchley Park team collectively. The Medal of Merit went to Travis himself. Turing got a thank you memo. Word spread anyway. Not officially, not through channels, but between cryptanalysts, between operators, between the people doing the actual work. By April, Hut 6 was asking Turing for advice on breaking Army Enigma. By May, Hut 3 wanted help with Luftwaffe codes. By June, American cryptanalysts visiting from Washington were quietly being shown the bomb and taking notes. The crib chain method appeared in classified U.S. Navy documents by September 1941, attributed to British techniques with no names attached. Turing became the invisible man whose ideas spread like wildfire while he remained unknown. The Germans noticed something was wrong, but drew the wrong conclusions. In June 1941, Admiral Karl Dönitz, commander of the U-boat fleet, ordered an investigation into convoy routing. His intelligence officers analyzed patterns. They concluded, "Enemy has developed advanced radio direction finding and is tracking our submarines by transmission patterns." Dönitz's response: stricter radio silence, shorter transmissions, more frequent Enigma key changes. Every change made German operations harder, but never once did they suspect the cipher itself was broken. The mathematics were impossible. Their mathematicians had proven it. 159 quintillion combinations. Unbreakable. They believed their own propaganda. In August 1941, U-110 was captured with a working naval Enigma and current codebooks. The British let the submarine sink after stripping it and told Germany it had sunk with all hands, keeping the capture secret. German Naval Command changed some procedures, but not the machine design. Why would they? Mathematics don't lie. In November 1941, German cryptographers tested Enigma security using captured British equipment. They concluded breaking Enigma by brute force would require 20,000 years of continuous calculation. System remains secure. They had no idea that British bombs were reading their mail daily. By the end of 1941, Bletchley Park was processing approximately 3,000 Enigma messages per day. Not all broke. Some used different settings. Some were too short for cribs. Some simply couldn't be solved in time. But roughly 40% of German military communications were being read within operational timeframes. That's 1,200 messages per day, revealing troop movements, supply shipments, attack plans, strategic intentions. The intelligence product was codenamed Ultra, higher than top secret. So valuable that Churchill received daily briefings. So sensitive that only 30 people in the British government knew the source. So critical that historians later estimated it shortened the war by 2 to 4 years. How many lives did that save? Conservative estimates, 14 million. That includes merchant sailors not killed by informed convoy routing, soldiers not killed by anticipated German movements, civilians not killed by extended bombing campaigns. Turing's crib chain method, that modification made in 47 minutes of unauthorized rewiring at 5:03 a.m. on March 9, 1941, fundamentally changed World War II's trajectory. And Germany never knew. They kept using Enigma, kept trusting it, kept believing in mathematical impossibility until May 7, 1945, when they surrendered. Even in captivity, German cryptographers insisted Enigma was secure. Some argued this until the 1970s, when Britain finally declassified the Bletchley Park operation. The war ended. Turing was 32 years old. The Official Secrets Act forbade him from telling anyone what he'd done, ever, under penalty of imprisonment. So when people asked what he did during the war, he'd say, "Clerical work, very boring." He returned to civilian life. No parade, no public medal, no acknowledgement. In 1945, the British government awarded him the Order of the British Empire, a mid-level honor typically given to competent civil servants. The citation said, "For services to the Foreign Office." It didn't mention cryptography, didn't mention Enigma, didn't mention saving 14 million lives. Turing became deputy director of the computing laboratory at the National Physical Laboratory. He designed one of the world's first stored program computers. He published groundbreaking work on artificial intelligence, the Turing test, that's still used today. He ran marathons, qualified for the 1948 Olympics, but didn't compete due to injury. He was brilliant, eccentric, socially awkward, and completely unknown outside academic circles. He lived in a small house in Wilmslow, Cheshire. He rode his bicycle to work. He was gay at a time when homosexuality was illegal in Britain. In January 1952, Turing's house was burgled. He reported it to police. During investigation, police discovered he'd had a relationship with a 19-year-old man. Homosexual acts were criminal offences under British law. Turing was arrested, charged with gross indecency. The man who'd saved 14 million lives was prosecuted for loving the wrong gender. His trial was March 31, 1952. He pleaded guilty, not because he felt guilty, but because denying it was pointless. The judge gave him a choice: prison or chemical castration via hormone therapy. Turing chose the hormones. The alternative was 2 years in prison doing hard labor. He was 39 years old. The hormone treatments began in April 1952. Synthetic estrogen injections. Side effects included impotence, gynecomastia, breast development, severe depression, and loss of mathematical ability. Turing endured it for 12 months. His security clearance was revoked. The Foreign Office considered homosexuals blackmail risks. He couldn't work on classified projects, couldn't visit the United States, banned under immigration law, couldn't continue research requiring government funding. The man who'd broken Enigma was now unemployable in his own field. He returned to pure mathematics, working alone, publishing papers that were brilliant but ignored. June 7, 1954. Alan Turing was found dead in his bed at 43 Adlington Road, Wilmslow. He was 41 years old. A half-eaten apple lay on his bedside table. Post-mortem examination revealed cyanide poisoning. The apple was never tested, but police assumed he'd laced it with cyanide from his home chemistry experiments. Coroner's verdict: suicide. His mother insisted it was accidental. He was careless with chemicals. Friends said the forced hormone treatments had destroyed him psychologically. The truth died with him. His obituary in the Times, June 16, 1954, ran 8 paragraphs. It mentioned his work on computable numbers, his work on artificial intelligence, his Olympic-level running. It said nothing about the war, nothing about Enigma, nothing about Bletchley Park, nothing about 14 million lives saved. The Official Secrets Act ensured his greatest achievement remained classified for another 20 years. Bletchley Park was nearly demolished in 1991. Developers wanted to build a housing estate. A small group of historians intervened, raised money, and established the Bletchley Park Trust. The site opened as a museum in 1993. By then, most of the original cryptanalysts were dead. The bomber machines had been destroyed in 1945. Security protocols required it, but engineers rebuilt one from blueprints in 2007. Visitors can now watch it run, clicking and whirring, breaking Enigma messages in 20 minutes exactly as Turing designed. There's a statue of Alan Turing at Bletchley Park, unveiled in 2007. Bronze, slightly larger than life, showing him sitting on a bench. Tourists sit next to it for photos. Most don't know his story, don't know about Mason's death, don't know about the 31-hour marathon session, don't know about the unauthorized modifications, don't know about the hormone treatments or the cyanide apple. They know he did something with codes and that he was important somehow. The plaque says, Alan Turing, 1912-1954. Mathematician, computer scientist, logician, cryptanalyst. It doesn't say saved 14 million lives and got chemically castrated as thanks. In 2013, Queen Elizabeth II granted Turing a posthumous royal pardon 59 years after his death. In 2017, the British government pardoned all men convicted under historical anti-homosexuality laws, the Alan Turing Law. In 2019, the Bank of England announced Turing would appear on the $50 note, released in 2021. Better late than never, some said. Others noted he broke the unbreakable code. We broke him. There's no equivalence in that exchange. The lesson isn't just that Turing was brilliant, though he was. It isn't just that Enigma was breakable, though it was. The lesson is that Nazi Germany lost World War II, partly because they believed their own propaganda. Their mathematicians said Enigma was unbreakable, so they stopped questioning it. They confused mathematical possibility with practical security. They forgot that systems are operated by humans, and humans are predictable, lazy, pattern-forming creatures. They handed Turing the keys to their kingdom every single morning at 6:00 a.m., when weather stations transmitted wetter. And they never noticed. Arrogance is expensive. German mathematical arrogance cost them the war, cost them 14 million casualties that could have been avoided, cost them everything. They built an incredible machine, they used it terribly. They assumed brilliance in design meant brilliance in execution. They were wrong. Turing proved them wrong every single day for 4 years, and they never knew. That's the final irony. Germany surrendered, still believing Enigma was secure. Their most fundamental assumption, their absolute bedrock certainty, was false, and they died believing it was true. If this story moved you, hit that like button. These forgotten heroes need people like you to keep their memory alive. Subscribe so you never miss another story of courage and innovation from World War II. And drop a comment below. Where are you watching from? Do you have a connection to this war? Did someone in your family serve? We want to hear from you. Thank you for keeping Alan Turing's memory alive. The man who broke the unbreakable code deserves to be remembered not just for his death, but for the 14 million lives he saved. For Mason's bookshop that never opened. For every convoy that reached port safely because a brilliant, strange, persecuted mathematician decided that mathematical impossibility was just another problem to solve.